last video talked about this formula right here, how to find your horizontal component and how to find your vertical component for your vector if this was your triangle. Okay? So right now we're going to use this triangle right here. What's our angle right here? What's our angle measure? 60. So that's 60. All right? What's our vertical component? Y. What's our horizontal component? X. And what's the magnitude of this one? 120. So if I wanted to find my horizontal component, I would write the cosine of what? 60 equals what? X over 120. Put this over a 1. So our horizontal component will literally be x equals 120 times the cosine of 60. Now some of you out there already realize that this is a 30, 60, 90 triangle, and you're like, why are you using trigonometry to solve for 30, 60, 90? Because we're practicing our trig. That's all we're doing. Understand, if you type that in the calculator, you will get x is simply equal to 60. So our horizontal component is 60. Our vertical component, everybody, is not going to be the cosine of 60. It's going to be what? The sine of 60 equals y over 120. So when you cross multiply solve there, y will equal 120 times the sine of 60 degrees. And if you type that into the calculator, it's not going to spit out 60 radical 3 if you're going to use the properties of 30, 60, 90. It's going to give you an approximate value. Okay? And the approximate value is equal to, what do you guys get? 103 point what? 0.8 what? 103.8. So 103.9. So about 103.9. So good. This is approximately, if you round to the nearest tenth, 103.9 newtons. This represents the horizontal. This represents the vertical. Now, I'm going to go over to this triangle right here. We are going to write horizontal, and we're going to write vertical. How are we going to set this one up? There's your x. Oh, not there, x. Right? This is your y. This is your x. This is your angle. Our angle is now what? 40 degrees. So the horizontal is what? The cosine of 40 degrees equals x over 180. So what will x equal? 180 times the cosine of 40 degrees. How do I set up the vertical? Sine of 40. Y over 180. Cross multiply, what do you get? Okay, just remember, you're sitting in a no yawning zone. Okay. Alright, I'm going to turn on my calculator real quick. You got to make sure your calculator's in what mode? Degree mode. Okay. There it is. Clear all this out. Second plus 712, just so we get some nice clear screen. Go to my mode button, make sure I get to degree mode. And I'm going to type in 180 cosine 40. And I'm going to type in 180 sine 40. And just for fun, we already did what? 120 cosine 60. 60, right? And we're going to type in 120 sine, sine 60, and that's how we got that 103.9. Okay? Now, we're going to look at this right here. These two numbers right here represent the horizontal and the vertical component for this guy right here. So what I want you to write on your paper right now, So I want you guys to write 137.9 and 115.7. 137.9 and 115.7. 137.9 and 115.7. For our other triangle, the vertical and the horizontal was 60 and it was 103.9. Remember, this part represents the horizontal component. This part represents the vertical. So this column right here is the horizontal components of not just one vector. This is the horizontal components of two vectors. This is the vertical components for two vectors. We add these together, and this gives us our final result. We add these together, we get 197.9 right here. We add these together, we get 6 pairs of 1, 9. You guys get 219.6. All right, so what does this right here represent? This represents what's called the ordered pair for the vector. I'm just going to call it the vector ordered pair, which gives you your horizontal component and the vertical component. Just remember, if you ever want to find your magnitude, put magnitude, you can put this in your journal, always equals the square root of whatever your horizontal component is squared plus whatever your vertical component is squared. So what number am I going to plug in right here? I'm going to plug in at 197.9. And what number am I going to plug in right here? 219.6. Okay? Except I'm going to use the calculator to get the whole thing. I'm not just going to use this approximate value. Let me show you what I'm going to do. I'm going to go to the calculator. I'm going to take the 137.88, right there. I'm going to add 60 to it. I'm going to use this number right here. Then I'm going to go up here. And I'm going to get the 115. And I'm going to add the 103 right here. Press enter. Now, once again, what does this big number right here represent? That's our horizontal, and this right here is our vertical. So watch what I'm going to do now. I'm going to scroll up, take that, and what am I going to do? I'm going to square it. Plus, go up, grab this guy, I'm going to square him, and this is going to give me a more accurate answer because I'm not rounding it now. I'm going to round it at the very, 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 very end. Okay? I'm going to press enter. And what do I have to do with this? I have to take the square root. 295.6, everybody. 295.6 is your final magnitude. 295.6 newtons. Just rounding it to the nearest 10. So if you had a person, okay, if you had a person pushing it at a 60-degree angle at 120 newtons, and you had another person. Try that one more time. Another person. There we go. Pulling it, right, at a 40-degree angle at 180 newtons, what can you not just do? You can't just add 120 to 180 and get 300. It's not going to be 300. What's it actually going to be? 295.6. All right. So, if you have no idea what we just did, you probably need to watch the previous video, which started the problem. This video ended the problem.